Okay, now we're going to be talking about truth tables. Now, this follows so closely along with what we just finished, talking about statements and whether a statement is true and false, and conjunctions and disjunctions. This is just a way of organizing the different scenarios that could happen. Okay, and now we're going to talk about how a truth table is set up. But before we do, let's again talk about negations. If a statement is true, its negation will be false because it's like I'm about to go to the store or I'm not about to go to the store. So if one's true, the other one's false. If one's false, the other is true. Okay, that's how negations work. They're always opposites. Conjunctions. If you don't remember conjunction, here's the symbol. A conjunction is an and statement. And the biggest thing we need to remember about and statements is the word both. In order for an and statement to be true, both must be true. Other than that, it's going to be false. A disjunction is the V one. It's an or statement. And I'm going to put the word either because if either is true, a disjunction is going to be true. So let's complete a truth table for each of these and notice what we've done here. Okay, for negations, this truth table, you have a statement, and that statement is P. Now, a statement is going to be one of two things. It's either going to be true or it's going to be false, and that's what we've listed below right here. This statement is either true or it is false. Now, let's go through both scenarios. If a statement P is a true statement, now what about not P then? If the original statement is true, then not P will be the opposite, false. If the original statement was false, then the not P would be the opposite or true. This is your first truth table, and this is how truth tables are set up. Now, in this truth table, we only had one statement. It wasn't a conjunction. It wasn't a disjunction. It was a simple statement, such as today is Monday. I don't know. I don't know what day of the week it is, but let's say that today actually is Monday. Well, if that is true, then today is not Monday would be false. What if today is not Monday? What if that is false? Then the negation of that would be always true. Now let's talk about conjunctions. And again, a conjunction would be an and statement. Now, if it's an and statement, then we have two different statements combined, and we're going to call them P and Q are those two statements. Okay, so what you have listed below, why is it TT, FF, and all that? What they've done is this is every scenario. Okay, if you've got a conjunctions of P's and Q's, either P is true and Q is true, or P is true and Q is false. Or what if P is false and Q could be true, or P is false and Q could be false? That's all four scenarios that you can have for P's and Q's. Okay, and we'll talk more about how to fill out this table in just a moment. But a reminder that the only way that a conjunction can be true is if both statements are true. And you have that in the first row. P and Q. The only way that P and Q can be true is if both P and Q are true. So then this would be true. Well, what if P is true and Q is false? Well, P and Q is false then. Because again, the only way that P and Q can be true is if both are true. Well, what if P is false and Q is true? It's still false because both are not true. Well, what if they're both false? Well, then this is definitely false. Okay. Again, it goes back to the whole 5 feet tall or 5 years old and 4 feet tall. Well, the only way that you could ride that ride is if both conditions were met. Now let's talk about disjunctions. Let me zoom in a little bit. For a disjunction, again, this is an or statement. The disjunction, okay, here's P and here's Q, and notice you've got the true and true, or the true and false, or the false and true and the false and false. You have every scenario here. Well, a disjunction is true if either one of these are true. So what if they're both true? Well, it's definitely true then, okay? But if either one of these are true, then your disjunction, because it's an or statement, either of them can be true, then the whole thing's true. So this is always going to be true unless both are false. That's the only time that you're going to have a false statement for that. And again, I think I've told you before, this deals so much with computer science. You're going to talk about and or gates and all that with logic boards. So lots of connections here. Okay, tips for constructing these. You're going to include columns for each statement involved. And that's what's happened here. Here there's a column for, let me erase it so it'll look better. You have a column for statement P and you have a column for statement Q. Well, what if there was an R? You'd have another column for statement R. You also include columns for all your negations. And so what if you had in this table, what if you had a not P that was also involved? Well, you would do another column over here for the not Ps. Okay. Lastly, include columns for the compound statements, and that's what you've got here. Okay, is your compound statement. So now it says, let's give it a try. Construct truth tables for the following statements: P or not R. Okay, so we've got two different statements here. This involves P and it involves R. Then you also have a negation of R, so let's go ahead and include a column for the negation of R. And then finally, we're going to do the entire thing, P or not R. Now, so let's do a truth table, and let's find out, when will P or not R be true? Now, is there a connection between this and what we just finished? Yes, this is the exact same thing, except for we don't have, well, what is statement P? What is statement R? We don't know. We don't have to know. Okay, now let's go through all the different scenarios. And now sometimes you can list these. P could be true and R true, or P could be true and R false. That's the only two scenarios. If P is true, then let's go with what if P is false? Then Q or R might be true, or R might be false. That's the two scenarios that you might have when P is false. Okay, so let's finish just filling this out then. Your next column is not R. Look at your R now. If R is true, then not R is false, because remember, a negation is always opposite what a statement is. If R is false, then not R is true. If R is true, then not R is false. If R is false, then not R is true. So now look at our last column here. Now we're going to deal with P, which is right here. And I'm going to highlight around this. Let me choose a different color here. We'll go with pink. And I'm going to, well, there we go. And I'm going to outline. We're dealing with P, which is this column. And we're dealing with not R, which is this column. You can now ignore the R column. Okay, so we want to know the truth value of P or not R. Okay, an or statement. Reminder, if this is true or if this is true, then the whole thing is true. So now P or not R. Here's P, here's not R. If either is true, then this statement is true. Here's P, here's not R. If either is true, then this statement is true. Here's P, here's not R. If either is true, they're not, then this statement is true. And it's not going to be. That's the only scenario, because look, false, true, that'd be a true statement. So the only way that this is ever false is if P is false and R is true. Then P or not R is false, and that's the only time it is. Okay, another one. Number 2. We're dealing with not P and Q. So let's do a column for P and a column for Q. Those are our two statements. We're dealing with P's and Q's here. We also deal with the negation of P. So let's do a column for not P. And then finally, what we're trying to figure out here is the not P and Q. That'll be our last column. All the different scenarios, true, true, or it could be true and false, or it could be this one's false and this one's true, or they could both be false. Now, do they have to be in that order? They don't. No, they don't. Okay, first off, the negation of P. Well, here's P. Let's do the negation of it. If P is true, the negation would be false. If P is true, the negation would be false. If P is false, the negation would be true. If P is false, the negation would be true. And again, I dealt with this column, and I pretty much did the negation as the opposite of that column. Okay, now, look what we're asked to do. Not P. What is not P? It's right here. So it's this and Q, which is this. So we're looking for the truth value of not P and Q. So we're asking ourselves, okay, first off, what does this and mean? It means that in order to be true, they must both be true. So the only time this statement is going to be true is if both of these are true. So look at not P and Q here. It's false. Look at not P and Q here. It is false. Look at it here. True and true would be the only time that that's true, because any time that either one of them are false, then the whole thing will be false. Now, again, what are we even doing here? A lot of people, are not making this connection. Let me scroll back up for just a second. Here is the last lesson we did, and let's look at just one of these. Not P or not Q. Okay, we could do a truth table on this, and we could find out, well, when is this true? And look at the scenario that we have. The first one's false, and the second one's true. And that led to the whole thing being true. Well, we could do a truth table on this statement right here and find out when would not P or not Q be true. Well, what if P is true and Q is true? Would the end result be true? What if P is false and Q is true? Would the end result be true? What if P is true and Q is false? Or what if they're both false? When does this whole statement produce a truth value of true? When does this whole statement produce a truth value of false? That's what we're doing with these tables. We're given the inputs of whether P is true or P is false, or whether Q is true and Q is false, and that tells us if the whole statement is going to be true or false. Okay, number 3. You're given two different statements. You have statement Q and you have statement R. And statement Q, and here's what I like to do. For this first statement, most of the time I'll just go down through here and do half truths and half falses. And then for statement R, I'll go back and forth, true, false, and you're going to cover, okay, true and false, false and true, false and false. That's every scenario, okay? Then you're going to have a column for not Q, and let's go ahead and do not Q. If Q is this, then not Q would be the opposite of that. So if Q is true, then not Q would be false. If Q is true, then not Q is false. If Q is false, then not Q would be true. If Q is false, then not Q would be true. Okay, now we're going to do the or. We're going to do not Q or R. Where's not Q at? Let me get rid of that box. Here's not Q. Where's R at? Right here. So what does the or right here mean? That means if either are true, then the whole thing is true. If either one of these are true, then the whole thing is true. So it would be true here. It would not be true here. It'd be true here, and it would also be true there. If either are true, then the whole thing is true. There's your truth table. So when is the only time, you can go back to your original statement now. When is the only time that this does not return a true result? The only time is right here. When your original Q is a true statement and when your original R is a false statement, that is the only time that this does not return a true result. Not P and not R. Okay, here's P and R. True, 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 false, false, true, false, and false. We've got to do each negation, so we got to do not P and not R. I'll do those in a different color here. So not P would be the opposite of P. So if P is true, not P is false. If P is true, not P is false. If P is false, then not P is true, and the same thing there. And then we're going to use R to do not R. If R is true, not R is false. If R is false, not R is true. If R is true, then not R is false. If R is false, then not R is true. It's always the opposites. Then finally, we're going to do the statement itself. Well, what about not P and not R? Since this is an and statement, the only way an and statement can be true is if they're both true, and that only happens down here. That's the only time that both of these statements are true, not P and not R. So the rest of the time, this is going to return a false statement. So most of the time, this statement will be false. Number 5, we're doing not P or not Q. So let's go ahead and do all the ones we're going to need. We need P's and Q's, not P's, not Q's. And then we're going to finally do what? Not P or not Q. Not P or not Q. So here's the different scenarios: true, true, or true, false, or false, true, or false, false. So again, not P will be the opposite of P. So that would be false, false, true, true. Not Q is going to be the opposite of Q. So that would be true, false, turns into false, true, true. And then we're going to do the disjunction of not P or not Q. So here's not P, here's not Q. The disjunction is going to be the or statement. So if either are true, then the final answer is true. So this would be a false. But the other ones have at least one true, so these will always be a true. Okay, something different happens on number 6. We actually have 3 different statements. And we have some parentheses around a couple of them, meaning, hey, we got to do these first. So we're going to have statement P, statement Q, and statement R. Now let's just work on that for just a second. Okay, you got to find out every scenario here. And here's the easiest way of doing it. For P is going to be true half the time, and it's going to be false half the time. If P is true, then Q is going to be true half the time and false half the time. If P is false, then Q is going to be true half the time and false half the time. So if you didn't notice that, I went down through and half of these over here, again, I made true, half of them I made false. And then of those, I made half of these true, half of them false, half of them true, half of them false. Now, if you set this up correctly, we should now be able to just, on this last column, go down here through here and do true, false. Because when this one's true half the time, this one will be true half the time and false half the time. And just continue that on. And you should end up with every scenario possible. A true, true, and a true and a false, a true, false, and a true, false, and a false, true, false, true, or false, false. That should be every combinations of scenarios that are possible here. Okay, next up, we've got to do, well, what about Q? Do the parentheses first. We're going to do Q and R. Q and R. And I'm going to put it in parentheses to remind us that's the part of our problem that is in parentheses. Okay, for an and statement, remember that the only way that Q and R can be true is if, I'm going to write it above, both must be true. So let's look at Q and let's look at R. So the only way that this can be true is if they're both true. Well, they're both true here, not here, not here, not here. It is both true here, but not here, but not here, and not here. Okay, and then we're going to do our final answer. P or, so we're going to do P or Q and R. Well, where in the world's Q and R? We just did that. Okay, so what we're going to do now, let me erase these circles over here. That was Q. We're going to do our Q and R section, which is right here. That one's done. That's this part. We're going to OR that. Again, that's the symbol for OR. We're going to OR that with P. Well, where's P? Right here. So again, here's the rule. Since it's an OR statement, if either these or these are true, then the final statement is going to be true. So the first scenario, you have true, true. So definitely true. Then you have a true, false. Since it's an OR, that'd be a true. You have a true, false. Since it's an OR statement, that is true. You have a true, false. Since it's an OR statement, that is true. You have a false, true. So that would be a true. Then you have a false, false, another false, false, and another false, false, which would all three of those be false statements. So most of the time, and you can see here, that's actually 5 out of 8 of the time, 5/8 of the time, this end result would be a true statement for P, Q, and R. And you can actually look here at your inputs and you can see, well, when is the final statement going to be true? Well, if everything was true, then the final one's true. If P and Q were true and R is false, then the final statement's true still. And the only time it's going to be false, you can look at the 3 scenarios down here. That's how you might end up with a false result, is if either one of these 3 scenarios happen. Next truth table. We're going to do not Q and P and R. Parentheses again, same as all of math, parentheses is going to be done first. So our 3 statements are P, Q, and R. If you don't remember how to set up this table, again, I do half truths, half falses. This is just a quick shortcut way. And I'm going to do half of these truths to be true. Half when P is true, half of those Q's will be true and half falses. Same thing down here, half truths, half falses. And then finally with R, you should be able to do true, false all the way down. And that's going to give you every possible scenario that you have. We need a column for our not Q's. We'll go ahead and list our not Q's right here. And we'll go ahead and do our not Q's. I'll do them in red, not Q's. So here's my Q's. So my not Q's are just opposite of those. So that'd be false, false, true, true, false, false, true, true. So we're done with our not Q's. Now we've got to do our parentheses. Let's do our P and R. With an and statement, they must both be true. So here are my P's and here are my R's. In order for this to be true, they must both be true. So it'd be true here, false there, true, true results in a true, true, false results in a false, false, true results in a false, false, false results in a false. False true would be a false, and false false would also be a false. So most of the time, P and R is going to be false. Then our final answer was not Q and, write that down, not Q and P and R. Okay, let's circle where that's located at. That would be, let me erase these circles. Not Q is right here. We're going to and that column with this column. Since this is an and statement, in order for this to be true, not Q would have to be true and P and R would also have to be true. So we can compare these here. That'd be a false, true, because they're both true. And then I believe we're false the rest of the way down. There you go. So if you have 3 statements, P, Q, and R, you make these 3 statements, not Q and P and R. In order for that to be true, here is the only way that you're going to return a true value for not Q and P and R. Okay. Next truth table. Looks like this one's going to be a rather large one. So you have, again, P's, Q's, and R's. That would be true, true, and I'm going to go ahead and repeat or fill that in. And if you don't remember how to fill that in, you can go back to the last problem and remind yourself. So let's see. Let me make sure I've got enough columns. Okay, I need I do have two negations here, so let's go ahead and do a not P and a not R. A not P and a not R. Those negations are always pretty easy. Not P, since P is 4 trues and 4 falses, then this would be 4 falses and 4 trues. And not R's, since it's true, false, this would be false, true, and then that would be all the way down. Oh. False, true, false, true, and false, true. Okay, so now let's do our parentheses next. Not P or Q. So in parentheses, I have a not P or Q. So let's find not P, which is right here, and let's find Q, which is right here. Since it's an or statement, if either is true, then this statement will be true. So here I have true, false, which will be a true. Have true, false, which will be a true. False, false, which is a false. A false, false, which is also a false. A true, true, which is a true. A true, true, which is another true. A false true, which is a true. And a false true, which is also a true. And finally, I've got to do that statement and not R. So our final line is not P or Q, which is what we just did, and the conjunction with that and not R. Okay, so we're going to be using this column with the not R column, and we're going to be finding the conjunction of the two, the and of the two. So in order for this to be true, they must both be true. So we're going to be using these two columns, and we're going to be asking ourselves, when is both true? And what you can do if you'd like to, just go down through here and say, oh, they're both true here. Erase that. They're both true here, and they're both true here. I believe that's right. And the rest of the time, you have at least one false, so the rest of those would be false situations. And that's going to be that finished truth table.